Here we have a short video over constructing a group frequency distribution. And I'd like to remind you what are all the attributes that we would need to have a group frequency distribution. The first thing we need is to have classes between 5 to 20. Second, we prefer our class width to be an odd number, but is not necessary. 3, classes must be mutually exclusive, so none of our data points should be in one class and then fit into a second or a third class. 4, our classes must be continuous. 5, the classes must also be exhaustive, meaning that all of our data points should fit into a class somewhere. And the last thing is 6, classes must have equal width. So we're going to use an example of the United States Electoral College back from 2016 to construct a group frequency distribution. Here we have all of our states, including Washington, D.C., and their Electoral College votes. Typically what you do is you take all of your raw data, this will be raw data here, and then we're going to organize it so that it's easier to construct our distribution. We're going to do our data by going from the smallest amount of Electoral College votes to the largest amount of Electoral College votes. Now that we have it organized, we have to first figure out how many classes are we going to use. To determine the number of classes, we need to follow all of the following bullet points. Find the highest and the lowest values in our data, find the range, then decide how many classes that we're going to use that class and our range to find the class width. We're going to divide, find the lower and the upper class limits, and then from the lower and upper class limits we can find the boundaries of our distribution. So if we go back to our data, the largest number, or the max, for Electoral College votes was 55 votes. The least amount of Electoral College votes that we have is 3. So the range would be the max minus the min. 53 minus 52, 55 minus 3 is 52. So there is our range of values. Now we need to determine the class width. If we use 7 classes, then each data will give us at least about 7 data points per class. So we're going to take that 52, we're going to divide it by 7, which gives us a decimal number. What we do with this decimal number is no matter what the decimal is, we'll always round up to the next whole number. So we're going to use a class width of 8. Now that we know that we're going to use 8 classes, let's construct a table. Our classes will go on one side, we have our boundaries in the middle, and then we'll calculate up all of our frequencies. Our first class will start with the minimum number. Well, the minimum number of Electoral College votes is 3. The class width is 8, so I'm simply just going to add 8 to 3, and that will be my next lower class boundary for the second class. 8 plus 3 is 11. Add 8 to 11, we get 19. And I can continue this out for all of my classes. There's all of the lower class boundary, all the lower class limits that we have. If the lower class limit of the second class is 11, I subtract 1 from it. That will tell me that the upper class limit for the first class is 10. You can continue this out by subtracting 1 from 19 to be the upper class limit of the next class, or simply just add 8 to 10, which will tell me that the second class will go from 11 to 18. You can add 8 to 18 and then get 26. And so on. So there's all of the lower class limits and the upper class limits for all of the classes that we're going to use for this distribution. Next, we need to figure out what the boundaries are. Well, the boundaries here, if you remember, should always end with an extra decimal point and a 5. We have whole numbers here, so it should be easy to subtract 0.5 away from 3 to get 2.5. Add 0.5 to 10 to give us 10.5. What you should remember then is that since our data is supposed to be continuous, our upper class boundary should be the lower class boundary of the next class. So it should continue with 10.5, and then if our upper class limit is 18, add 0.5 to it, it'll go up to 18.5, and so on to continue for the rest of the boundaries of this distribution. And then the very last thing that we would like to do is tally up the data and find all the frequencies. So we would go back to our data points and see all the electoral colleges that fit between 3 and 10. there are 34 states that have electoral college votes that are between 3 and 10. And then we have 11 that fit between 11 and 18 electoral college votes. We have 2 that have electoral college votes between 9 and 26, 2 that are between 27 to 34, 1 between 35 to 42, none with 43 to 50, and then finally there is 1 with electoral college votes between 51 and 58. So there's how to find, or how to construct